This is Bridges section 5.4 video part 2. Anyway, I was cut off and I was rushing, to be honest, at the end of the last video, so I'm going to go ahead and finish up this right here. So anyway, since the x minus 2's match, that comes out to the front. You've got 4x squared plus 3 left over because you've got this piece here and this piece here. Once the x minus 2's are factored out, that becomes that piece right there. All right, now, the assignment for this part would be page 334, 24 to 34 even, and 50 through 60 even. All right, so now let's look at that special form stuff. All right, so the first thing I want you to remember is that when you have two things that are squared like this, that's what you get when you have u minus v times u plus v. Probably should have used a and b, but whatever, it's fine. So, from before we started on this side and ended up here, but now I want to take this thing right here and turn it into this thing right here. So basically I'm factoring it, I'm going backwards. And so this is called the difference of two squares, mostly because you've got a square there and a square there with a minus between them. So, anytime that you have a perfect square minus another perfect square, you can factor it in this fashion. Notice that x squared is x squared, and 64 is 8 squared. So this would factor into x plus 8 and x minus 8. Notice that the minus and the plus, it doesn't matter what order they go in. You can put the plus first, you can put the minus first, you can mix it up depending on what kind of day you're having. It really doesn't matter. Now, it's a little more complicated if you have something like this, 49x squared minus 81y to the fourth. You might not notice that those are two perfect squares. Well, you probably know that 49 and 81 are perfect squares, and x squared is a perfect square. But y to the fourth is actually a perfect square as well. And if you think about what multiplies by itself to get y to the fourth, y squared times y squared is y to the fourth. Therefore, this factors into 7x minus 9y squared and 7x plus 9y squared. And again, it would probably be a good idea to pause this video periodically and try to work these problems, okay, so that you get a little practice in. All right. Now, we've looked at this difference of two squares, and that's going to be pretty prevalent in what we're about to do. So, if I want to factor something completely, first of all, that's code for there's probably more than one step involved. And secondly, that means I want to break it down into as small of pieces as I possibly can. So, if I've got 125x squared minus 80, well, notice that 125 and 80 aren't perfect squares. But I hope you also notice that 125 and 80 are also divisible by a certain number, that number happening to be 5. So the first thing I'm going to do, and always your first line of defense when you're factoring, is to try to come up with a common factor and pull that out first. Because a lot of times that makes your numbers smaller if you can, and it also reveals certain patterns. So if I take out a 5, 5 goes into 125 25 times. So that's 25x squared. minus 16 because 5 times 16 is 80. Well, if you look at this, that's a perfect square, that's a perfect square, and that right there is a minus. Therefore, I can factor that into 5x minus 4 and 5x plus 4, because 4 times 4 is 16. 5x times 5x is 25x squared. And notice that I still have to bring down this 5 that comes from here. So that goes to there. And this is completely factored. There. Now it's not messy. All right, let's try another one. So, let's say I want to take x to the 4th minus y to the 4th. Well, just like on the previous page, you know that x to the 4th and y to the 4th are perfect squares. So this would be x squared minus y squared and x squared plus y squared. Now the trick here is knowing that you're not done. Because if you look at this guy right here, you'll see that you have a perfect square minus another perfect square, which can be factored again. So this piece factors into x minus y and x plus y. Now the same is not true for plus. A lot of kids think that, well, if it's x squared plus y squared, don't write this part, by the way. So if it's x squared plus y squared, that's got to be x plus y times x plus y. The problem is, if you multiply this out, if you FOIL it out, you get x squared plus 2xy plus y squared. And then some kids think, okay, well, if it didn't work with plus, let's do it with minus. Well, if you switch these two things to minus, all you're going to do is switch this sign to minus. This sign is going to stay plus because of the fact that minus times minus is positive. The point is, you're still going to end up with this 2xy in the middle, and that's nowhere to be found in this piece. So x squared plus y squared is not factorable, so you just bring that down. And you have something that's factored completely. I guess I should probably erase this just in case people are like, what is that? What does that mean? Ah. Anyway. So, let's try a couple more of that type, and then we'll call this a video. All right. 81m to the 4th minus 1. Think about it. 81 is a perfect square. So that's 9m squared and 9m squared. And notice that 1 times 1 is 1. You put a plus, you put a minus, and that's the beginning part. Now notice that this first piece is not factorable, but this second piece, once again, you have perfect squares. So this would be 3m minus 1 and 3m plus 1 in some kind of order. Doesn't really matter what order they go in. All right. Now, let's see what else I have. How about 4xy cubed minus x cubed y? Now kids will take one look at that and freak out because there are two variables in it. But I want you to understand that it's no more difficult than anything we've done so far. First thing you have to do, always your first line of defense when you're trying to factor, is you've got to try to find a common factor. Well, 4 and 1 don't have a common factor other than 1, but notice that there's at least one x and at least one y in each term. So I can take out an x and I can take out a y. So if I factor out xy, the 4 is going to stay. The x is going to disappear because I've already factored it out. And then if I take a y out of y cubed, I'm going to be left with y squared. Minus. Now if I take an x out of x cubed, I'm going to end up with x squared. And if I take a y out of y, the y will be gone. So it now sits as xy times 4y squared minus x squared. Well, if you notice, this baby right here is the difference of two squares. So just like everything we've done so far, keep the x and the y. This will be 2y minus x and 2y plus x. And that's basically how the difference of two squares goes. All right. The assignment that goes with this is on page 335. I need 66 through 78 even and 100 through 104 even. Thank you.